I want to welcome everybody to the start of the new year. This is going to be our first simulation, Build Your Simulation IQ session. Today, since it's a new year, we're going to start off with getting started with Autodesk Simulation CFD. We're actually having Marwan present. He's part of our team. He's actually got a long history with Autodesk and the Al Gore mechanical product. He's been using that product for years, and in the past year, he's pretty much started transitioning over to helping a lot more on the CFD side. So we asked him to sort of think back to the past year and present on his experience with picking up the tool, where he learned the software, and we thought that'd be a great way for presenting that to people that are also picking the software out in the field. So if you can go to the next slide, Marwan. Here we go. So for most of the people that have joined, you probably learned about it at the forums, and we also sent out a whole bunch of direct emails, which we've stopped doing on at least a weekly basis. So at this point, if you know somebody that wants to join, you can send them that link of where do we announce, and that actually will list all the different webinars that we have going on. We have some with AutoCAD, with the different simulation products. There's also one going on for just general installation and licensing. This is actually going to be our 12th webinar for CFD, and we got a long list of ideas that are coming with the new year, and one exciting idea that will probably be a multi-week electronics model that will cross all the different simulation products. So cool stuff to come, and this is something that we all take a lot of pride and joy in. So next slide, Marlon. Okay, so in terms of November and December, we had a lot of different knowledge-based articles. These are articles that we write in the support side after we help you on a sort of a phone or web case that you've created, and sort of time for us to reflect on what question or issue you really had and then what the real solution was. So a lot of how-to type questions you can see there, as well as a few others. So I encourage you to go to this link or go to the forum and see all the new articles that are listed within this post. At this time, we do have some poll questions that I would like to just pull out, and we only got 4, and it's kind of just for us to understand what type of audience we have right now. Just so you know, right now we've actually got about 60 attendees, which just went to 61, so there are more and more people joining in as we go on. The first question that I have here is, I'm trying to understand a little more of what you're trying to do at your company. I'm assuming a lot of people who are joining are new to using CFD, and there's probably some that have been using it for a long time and joining in with other people that are picking up at their company. So this question is kind of asking, how many different what-ifs would you be doing at your company? If you're just trying to validate one model, that's great. If you're trying to just do a quick design change on a project, so maybe you're doing 1 or 2 different design changes, that's interesting. If you're really early in the design phase and you're doing like 20, 30, 40 different design changes, that's exciting, a lot to do. You can use the software to do that as well. If you're just new to the tool, trying to expand your skill sets, great, welcome. Got about 40% of the votes coming in. About 50% of the people right now are kind of in that early design phase, and a good 32% right now are kind of that unknown, just picking up the tool, growing the skill sets. Okay, so we're at about 75% voted. So let me close that out, and I'll share that with everybody, just so you can see, what kind of audience that we have. Definitely heavily in the early design phase, which is great. That's kind of the bread and butter of our user base. Okay, let's hide this one. This is more of experience at your company, your team specifically within your company with CFD modeling. Maybe you've just purchased, been using it for years, but you're new. Consulting for quite a few years, so you kind of outsourced it, and now you're looking to bring it in-house. Or you've got experience, and your team's got experience, and looking to see what else you can pick up in terms of maybe different types of simulations or what. Okay, so definitely heavily on the lots of experience in-house, but you're pretty new to this tool, which is great. This is a good fit for you then. Okay, let me close this out. And just share that briefly, just so your own curiosity. And these last two will go really quick. This will kind of help us maybe later on we start getting to the Q&A of specifically on application. If most people hear electronics, for instance, which that was a quick early vote, then we'll spend some time there as best as we can. Got a lot of building design, flow control, electronics, no motion, and a small group of sort of automotive, aerodynamics, and aerospace. So someone with motion just voted. Okay, I'll close it out in 2 seconds. There we go. I'll share that one with everybody. And this is more of, do you know how to get help? Between the forums, contacting support, where do you usually go? Okay, definitely heavy on the forums, which is good. Within the support team, we try to stay an active presence there. And we do have developers that hang out there as well, so it's a good place to getting help. Okay, let me close this out and share that to everybody. And at that point, I'll hide. And there we go. So Marwan, next slide. Thanks everybody for voting. And at this time, I'll hand this over to Marwan.
All right. Thank you, Royce. Thank you, everyone, for attending. As was mentioned, this is getting started with Simulation CFD. I have a few slides here, not too many, but then I'm going to get into doing some examples and showing you how to use the software. And I'm not going to get deep into any of the topics, but we're going to show you how to do some of these things. So in today's agenda, as you see, there's a lot of items to cover. So we won't be going too deep into any of them. So we're going to start by talking a little bit about the capabilities of the software, typical uses, some of the resources available to you, what kind of CAD geometry do you export and how do you export it into Simulation CFD, the concept of study, design, and scenario within one basically file, a couple of the geometry tools, how to manipulate the model, rotating and hiding and doing things like that, selecting, some basic meshing techniques, how to set up a model from beginning to end, and by setting the materials, the boundary conditions, a couple of things in the solve dialog, how to review the results, looking at slice planes or cut planes, how to use the bulk calculator, a quick look at the decision center basics, and of course, that's all going to be done through going through some examples. Some of the capabilities that you have with Autodesk Simulation CFD, you can do, of course, fluid flow, compressible, incompressible, steady state, and transient. And you can also do heat transfer, either alone or with fluid flow. That's also steady state, transient, forced convection, or buoyancy. You can model phase change, smoke extraction and visibility. You can do motion, you can do rotating machinery, and you can do free surface modeling. Some of the typical uses of the software is for designing valves, pumps, for electronics cooling, aerodynamics, HVAC, data centers, and process heating and cooling. Some of the resources available to you, of course, in addition to what Royce has mentioned, and the forums, the tech support line, and so on. This is basically mostly the documentation, new user quick start, the tutorials that come with the software, the what's new in Simulation CFD 2013, 2014, and 2015 that gives you kind of a historical progress of what kind of things we added and capabilities we added to the software. Best practices guide, and some of the sections and the user's guides as the GUI, graphical user interface, surface materials, turbulence models, salt dialog, of course, and many more. These are just examples to start out with.
So let me just emphasize one thing. When Marwan started picking up the tool, the question is always asked, where should I start? And he had some experience with CFD, with where he was previously with an Autodesk. So really, we had him go into the new user quick start and go through all the tutorials. And even if the tutorial doesn't really cover an application that you do, it reinforces some of the clicks and picks. The tutorials don't necessarily answer why you're doing something. It's just kind of helping you learn a workflow. Once you kind of learn that workflow and you start understanding what's going on, that's when it's a good idea to go into the what's new, understand some of the progression of new features added in, where we're kind of going with the software. And at that point, pick the best practice that means most to you. If you do electronics, read through the natural convection portion of electronics. It's very deep, and it points to different parts in the help as you start reading through that. Then lastly, these 4 sections is usually where I point people to in the user's guide to really start reading through some of the different features, in terms of other parts of the user interface and so forth. So I just want to emphasize some of that a little bit. Sorry, Marwan, for chiming in.
No, thanks, Royce. Next slide. The next couple of slides, basically, where can you bring in a model? Some CAD formats you can import. This first slide shows you the CAD packages that you would need to have the CAD package installed on your computer to be able to import the model. This would be Autodesk Inventor, Autodesk Revit, Autodesk Fusion, PTC, Pro E, Creo, Creo 1.0, and so on, UGNX, Unigraphics, SolidWorks, and SpaceClaim. So for those, you would need to have the software installed on your machine, the CAD package, that is. Some other CAD formats which would support direct import, PTC assembly, PTC chart, and so I'm not going to go through all the list. Because we're going to make this available to you, and this is actually also in an article that is available in the Knowledgebase. But these slides will also be available to you. Just for the sake of time, I'm not going to go through all of them. Before we get into the questions, of course, we're going to go through some examples here. I'm going to minimize my PowerPoint presentation and go to some models that I have here in Inventor. So this is a one-part model. So of course, when you are doing, let's say, a fluid flow, you want to have your fluid domain modeled as a CAD, either as a CAD part, which is what you have in this case. This would be the fluid flowing through some valve. So we're not really interested in the valve itself. We're interested in the fluid inside of it, the volume of the fluid, and this is what this CAD model represents. And in the next example, I'll show you if you only have the body of, let's say, we're going to have like a Y junction, how to generate the fluid inside of Simulation CFD. But for this first example, I have the fluid that is flowing in the valve. Model here is just a one-part model. I will click on Simulation here and go to Launch Active Model, at which point it's going to fire up Simulation CFD and present me with this dialog. The study name is the same name as the file here, which is just valve. So you can see we have study, design, and scenario. The study is basically the overall file name. Under that one file name, you can have multiple designs, and under each design, you can have multiple scenarios. So the difference between one design and the other would be a different geometry. Okay, so you can model, well, what if I change the geometry? What's going to happen? Under each design, you can have different scenarios where you can change the boundary conditions. Well, what if I change the temperature? What if I change the flow? What if I, keeping the same geometry but different boundary conditions, or materials for that matter. So basically you have 3 levels here. The biggest level is the study. Under that you have designs, and under that you have scenarios. You can keep those as a default, or you can give them different names. That is up to you. I'm going to stay with the default names and click on Launch. And when I click on that, I'm going to see my part here, my volume, appear in Simulation CFD. And here it is. If you're familiar with, let's say, how Inventor works as far as rotating and panning, Simulation CFD is set up the same. If you click on the mouse button and drag it, it's going to pan the model. If you hold down the Shift key, click on the mouse wheel, and that will rotate your model and so on, and you have the view cube. Up here, you got your geometry tools, which we're not going to use for this example. Materials, boundary conditions, initial conditions, mesh settings, if you have motion, and the solve. So they're laid out logically here. So as such, the first thing I'm going to do is set the material. You can see that it is set here to unassigned. I can select the part, which is one part only here, and click on edit. That's one way of doing it, or I can click on the edit button up here. Either way, when the part turns red, it indicates that it is selected. If you have selected more than one part, one way to make sure that you have the correct number of parts is if you look at the lower right corner of your screen, it says one volume selected. Or let's say if you had selected surfaces, it's going to tell you how many surfaces you selected. You know, it's a sanity check to make sure that you didn't select more or less than you need to select. Again, not applicable in this case, you only have one part. Click edit. This is the material selection screen. The software comes with a whole bunch of default materials, and on top of that you can make your own materials. So in this case my type is fluid, but you have fluid, solid, resistance for something like a filter, internal fan or pump, centrifugal pump, check valve, rotating region, PCB, compact thermal model, LED device, thermoelectric component, heat exchanger, or heat sink. So there's a lot of basically types of volumes that you can set, and under each type, in this case we have a fluid, under each type you have a bunch of materials that you can select from, and like I said, on top of that you can create your own. In this case we have water, and I'm going to click apply. So I've set the material. I'm going to click next on boundary conditions. This one's going to be a simple one, and what happens by default is it switches to surface. So if I click on it, it's only going to select that particular surface. I'm going to click on that surface, and I'm going to grab the edit from here, and in this case I'm going to set inlet velocity. You can change units, so you can have different unit for each and every boundary condition. So you don't have to follow the overall unit system in the model, and hence you don't have to make conversions on the fly and subject yourself to possibly making a mistake with the conversion. In this case, I'm going to set this to 2 meters per second, and this arrow here shows me the direction of that flow, and I'm going to set that to actually fully developed. Or actually I can set, since I have such an inlet distance here, I can leave that as constant. There's enough distance for it to get developed. So that's my inlet. I'm going to rotate by hitting the Shift key and the mouse wheel and set the outlet to a pressure of 0. That usually signifies an outlet. Anything that you don't apply a boundary condition to here, this is considered as non-slip. So basically it's fixed. And again, this is the volume representing the fluid going into the valve body. We don't care about the valve body itself. It didn't even come in. Next, I'm going to go to the mesh sizing and click on auto size. The options here are either automatic or manual. The easiest way to do it is automatic auto size. These blue dots here give you an indication of how dense or coarse the mesh is. Of course, if you have finer features in the model, you would get more dots to be able to capture that. And I'm going to just leave that as the default. We'll go in a later example. I'll just show a couple of things you can do with the mesh, but not in this example. So we did the material, the boundary conditions, the mesh, and next I'm going to go to my solve. Under physics, I'm only going to keep this checked. The flow, I'm not going to do heat transfer in this model. It's going to be incompressible, which is the default. That's fine. Under control, I'd like to change the advection to the new advection method that we have, ADV5. That's the one that we recommend that you use. And they might actually change it to the default. And I'm going to increase the number of iterations to 500. It will stop once convergence is reached, so it doesn't necessarily go up to 500 iterations. And if it doesn't converge, you can always solve for more iterations till you reach convergence. At this point, I'm going to go ahead and click on the Solve button. I'm done with setting up my model, and I'm going to click on Solve. It's going to create the mesh and start doing the iterations. And by default, the mesher creates a boundary layer mesh at the walls. You have 3 layers. This way, it will capture. You will have at least 3 nodes to capture the flow and the transition between 0 velocity and whatever the actual velocity was going to be. Basically, to capture the boundary layer effect. So this will run. What I'm going to do is I'm going to bring up the model from a backup folder just to show you the results. We don't have to sit here and wait for it. We want to talk about other things here. So we're going to go here and go to our models, go to Valve, and go here and open the. So you can see there's only one design here. If you had more than one design, you'll see more folders. And we're going to open this. So this is basically set up the same way. It converged at 440 iterations. The convergence plot, I'm actually going to stop this here. And if I click on the results tab up here, that's where I would see my results. So if I'm looking at it in this view and I'm looking at the velocity, everything is at 0. And that's to be expected because I'm looking at the walls. If I rotate this, this is my inlet velocity. And if I rotate it over here, that's my outlet. Nothing too exciting in this view. Really what I want to do here is I want to go to planes and add a slice plane. And by default, it added a splice plane perpendicular to the x-axis. So what I can do is I can, when I select that plane, the outline turns to yellow, from red to yellow. I can left-click my mouse, and I want a slice plane actually perpendicular to the y-axis. So I select y, and I get something like this. So if I look at it from the top, I'm slicing the model basically in half. And now I'm looking at the flow that looks more exciting than the previous view. So now I can see the flow inside this valve. And if I, again, click on the slice plane and click on the edit slice plane, I can do a bunch of things here. Some of the things you can do is you can show the mesh if you want to look at what the mesh looks like. So you go to shaded with mesh, and you can say, okay, that looks good, or maybe that doesn't look good, depending on your application. If I zoom in, you'll be able to see the boundary layer I mentioned here. Go back to just shaded. You can also look at the vectors. If I click on vector settings, right now it's not showing any vectors. I will change that to velocity vector, and it will show me the velocity vector in addition to the shading based on the velocity. If I don't want the shading, I can go back and just go to outline and look like this. And I can add more vectors by moving the slider down the grid spacing. So it'll show me more and more vectors. And right now they are the same length independent of the velocity magnitude. If I wanted the faster velocity to show as longer vectors, I can click on length range and play with these lengths here. So where you have faster flow, you're going to have longer vectors. Another thing I can do with a splice plane is look at the bulk results. To do that, I'm going to change the plane. And speaking of planes, just let me show you a couple of things. You can move the plane by dragging these arrows and the X, Y, and Z. Well, it doesn't make sense to drag it here, but you can do that. Also, if I left click on the plane and click this button here, align to surface, I can align it to the inlet or to the outlet. So now I aligned it to the inlet, where I can use the bulk calculator to, let's say, calculate the mass flow and whatever units I want, let's say kilogram per or pound per hour. And if I click calculate, it's going to give me that value, how many pound mass per hour. I can request any of those output results. In the next example, since we have temperature as well, it'll be more interesting to see what kind of results this bulk calculator gives me. Again, if now I don't want any slice planes, and I can add more and more slice planes if I want, and I can remove them. I moved it, and now I'm going to display this entire model as shaded. So basically back where we started. That's all for this example. I'm going to show us the next example. The next example here is not this one. It's this one. It's like a Y valve. And this, the CAD model shows you the actual valve. The fluid volume is not modeled here. We're going to create that inside of Simulation CFD. So this shows the basically solid piece that the fluid will flow in. Again, I go to Simulation and I launch my active model. We're going to go back into this just in 1 second here. I'm going to X out of it, this geometry tools. And as you can see here, there's no fluid volume. This thing is hollow, as it should be. That's the metal part. So how do we generate the fluid inside of it if we didn't do that already in our CAD model, which most people don't? To do that, I will go to the geometry tools. And basically what I need to do is I need to plug these 3 holes, create surfaces to plug these holes, and then I can generate the volume inside once it's watertight. That's going to be quite easy here. I'm going to go to Void Fill, to the Void Fill tab here, and select Edges. So I'm going to select this edge and build the surface. Zoom back in, and select this edge and build another surface. Then rotate it. And lastly, select this edge and build a 3rd surface. So I built 3 surfaces. And now if I click on Fill Void, let me just move this here. You're going to see that another part will appear here, or volume will appear here when I click on Fill Void. And
Marwan, while that's
yes.
going through, one thing I just want to point out, somebody that's new to the software, and let's say you bring up this geometry tools window and you don't really remember the workflow, pretty much in every single window or widget that kind of floats, you'll see a little blue question mark. So right below the Build Surface button, you'll see a blue question mark. All these are context sensitive. So if you click on that, if you do that right now, that'll bring you right to the online help system for using the Void Fill tool. Talk about when to use it, how to use it, and things like that. One thing I do want to emphasize, this is a handy tool for when you bring in geometry to get the fluid volume on the inside. I don't consider it the most robust workflow if you're doing a lot of design. If you're just doing a one-off, it's great. If you're doing design changes, I would encourage you to actually create caps inside of CAD so that you don't have to keep doing this every single design change, because this doesn't really go from one design to the next all that well. So I want to kind of make people aware of that. So there are 2 workflows. If you bring in a cavity into CFD, it will automatically generate that extra volume for you. So I'm just trying to save you some clicks.
Yeah, if that cavity is watertight.
Right. Right.
Yeah, and that's why you would add those caps to make it watertight, and then this volume that I just generated would be automatically generated, and you won't have to do that.
Right.
And sometimes you don't maybe even have that edge. If you have some kind of spherical surface or rounded surface, you might not be able to grab an edge. And of course, then you can suppress those caps and get them out of the design. So right now, again, in this case, I'm only interested in the fluid, but still, I would need to specify a material for the pipe itself. It's going to be solid, and anything would work really. Let's say aluminum. Doesn't really matter. And the fluid is going to be, in this case, water. Oops. And now I can select this guy here, right click, and suppress it. Not remove, suppress. Remove would remove the material, so you're going to have to redo it. What you want to do is suppress it, and you'll see it's crossed off. It doesn't hide it. I can hit the control key and my middle mouse wheel and hide it. And this is the actual volume that was generated by Simulation CFD, by the software. So this is my flow domain. What I'm going to do here is I'm going to now go to boundary conditions. I will select this surface, edit. I'm going to do two things. I'm going to specify a volumetric flow rate of 3 GPMs here. So I'm going to go down to gallon per minute and set that to be 3 and apply. I'm also going to set that at a certain temperature, so it's going to come in at 50 degrees Fahrenheit. So we got metric and English units. That doesn't matter. That's fine. This surface here is going to be similar but a little different. Also volume flow rate. But that's going to be, again, GPM. And it's going to be 4 GPMs. And it's going to be at 100 degrees Fahrenheit. So these two are my inlets. I will rotate. Now if I try to solve this without specifying an outlet, you're not going to really get anything out of it. To specify an outlet, we typically set the pressure to be equal to 0. Now I'm going to go to my mesh sizing. I'm going to go to auto size. I'm going to do something here just simple. I'm going to select this part. I clicked on the edit button. I want to edit my mesh. It brings up this dialog here. I'm going to select this part, which is the only part, of course, I have. And I'm going to move the slider down a little bit. So I'm using a finer mesh than the default mesh. I click on Apply Changes and Apply. So I changed my mesh by making it a little finer here. Another way of changing the mesh would be perhaps to define a refinement region, a volume box that you would have a finer mesh. I'm going to go to my Solve dialog. I'm going to go to Physics. And in this case, I do want heat transfer. So I'm going to click on that. What else? I'm going to change the solution advection to 5 again. And also change my iterations to 500, even though it might not go up to that many. And I'm ready to solve now. So I click on the solve. And what you'll see is it's going to generate the mesh. And go through the solution. And as it's doing that, I'm going to go ahead and open the one that is already done so we can look at the results. So this one here is running, and you can watch the convergence. And this is the one that already ran. I'm going to click on results. And in this case, I already specified a slice plane. Let me go ahead and get rid of it and go to view shaded. So that's what it's going to look like. This is my velocity. It's faster here than it is up here. I can go and look at the temperature by just going to result, go back to global and look at the temperature. So this is what the temperature looks like. Obviously this is not a good mixing device. At the outlet here you still have cold temperatures up here and warm temperatures down here. So if your goal is to get a uniform temperature out of it, that is not the geometry for you. Let's go ahead and create a slice plane here. Now this is not going to look too different than what you see on the outside. I'm going to create a slice plane perpendicular on the exit plane here and look at the temperature using the bulk calculator, which gives you a weighted average based on the mesh size. So when I click on this, rotate my model and select this plane, and then go on bulk, I can look at the volume flow rate and the temperature. I'm going to change this to gallons per minute and degrees Fahrenheit and click on calculate. Volumetric flow rate is 7 gallons per minute, which is good. That's 3 plus 4. And my temperature is about 78 degrees Fahrenheit. An average temperature here. Of course, it's not nicely distributed. So in this example, we did both fluid flow and thermal calculations. I'm going to go ahead and stop this analysis here by clicking on the solve, which will bring up my solve dialog. So anytime you want to stop the analysis, you can do that and click on stop. Now, depending on how complicated the calculations are, it might take a few seconds to stop or might take a bit longer to stop. So I went up to the 90th iteration here before I stopped it. Now my third example might be more interesting than these first two. And this example is of some electronics enclosure. So what I have here is a box. If I hide that, I have some board with a bunch of, with a heat sink, some maybe capacitors, a couple of other parts in it, and a box, and it's basically in my CAD model, this box that I hid is a thin-walled part. So there's really nothing. It's empty on the inside. Inside the box, except for this board and the components on it, it's empty. And that's where you're going to see when I bring in the model into Simulation CFD. Since this is a watertight box, it will automatically create the air volume, or I shouldn't call it air, just the volume inside of it. I'm going to turn the visibility back on here. And again, I'm going to go to Simulation, Active Model, and click OK. And And here it is. So this is my box, and if I hold down the control key and click on the mouse wheel, it will hide that part. And this part that appeared under it is this volume 10, and that is the volume that was generated automatically by the software, since the box was a watertight box. And if I hide this, I'm going to see my board with the components on it. One thing I've found useful to do sometimes would be to group certain parts together. This way you can hide them easily and show them easily and edit them more easily. To do that, I select them. Now you don't have to hold down any keyboard key here. When you click or unclick, it adds or removes the part from selection. And down here it says 4 volumes. So I know probably the air part that I hid is already selected. So this is not what I wanted to do. So I can do one thing. I can either show all parts, or I can hold down my control key and scroll the wheel to go back one step in terms of hiding and showing parts. And I can left click on this part again and remove it from the selection. Now I only have 3 volumes selected. I don't have to hide this part. I know which 3 volumes are selected. I can right click and go down to group and create a new group. And that would be, let's say, capacitors, or whatever it is you want to call it, and hit OK. And this appears here. So now I want to hide this, and I want to deselect all. Now if I select this group here, right click, I can just hide it with one click. So you can make complex selections and group them together, and they will be available for you in the tree here. Now I'm going to show that again. So let's show everything, and I'm going to select the outside box here and set that to a solid and make that aluminum. I'm going to hide that by holding the control key, clicking the mouse wheel. Now this is my air volume, and select it, edit it, change that to fluid, air, apply, hide that. This is going to be solid and aluminum, maybe a different type of aluminum, 6061. Let me show you one thing since I'm talking about materials. If you click on edit, you'll be able to see the material properties. These are straight from the Autodesk CFD, Simulation CFD library. Conductivity, this is isotropic, so same value for X, Y, and Z directions. And the density, specific heat, emissivity, electrical resistivity. These are the materials that are built into this material, the aluminum 6061. If you want to create your own, you can give it a name, and you can save it to your materials. You can type in whatever values that you want, and then apply and save, and it will save it to your own material library, so you can go back and pick it. You don't have to enter numbers every time. This is the case for any kind of material. Now I click apply. This here is going to be also a solid and going to be a printed circuit board that I'm going to pick up from the library and the Y direction in this case. And again, if I click on edit, I'll be able to see the properties for this PCB. And if you go through the tutorials, it will show you how to create your own materials. Lost my selection, I didn't click apply. That's okay. And finally, these 3, they're not crucial. I'll make those solid, maybe acrylic, and hit apply. So at this point, I set all the materials that I wanted to set. Next, I'm going to click on boundary conditions, and I'm going to select by volume. Select these three here and specify total heat generation. Let's make that watts. Let's say 10 watts. So each one of these will be generating 10 watts. And let's say there are other components here that I'm not modeling, and this one is going to be generating some heat as well, maybe 20 watts. Next, I'm going to show the air volume. Now, if I show everything, I have to hide the case, and I'm going to switch back to surface. These are going to be my outlet here. So I'm going to select those two and set the pressure to 0. I'm going to rotate the model. I think I showed the outside again. I'm going to hide it, and I'm going to go back to surface, select this surface, apply a certain flow rate, 50 cubic feet per minute. And a certain temperature. And that's going to be 70 degrees Fahrenheit. Now, one thing that you may or may have not noticed here is when I specified that flow rate, I wasn't sure which direction it was going. And so if I click on Edit, or if I pick it up from here, and edit it, I'm not seeing that arrow, so I'm not really sure if I have it specified in the right direction or not. So what I'm going to do is I'm going to hide a couple of surfaces here and rotate the model and go back to editing this. And you can see that the arrow is pointing in the wrong direction. So that's definitely not what I want. I'm going to click on the direction here to reverse the normal, and now it's going in the right direction. I'm going to go now to my solve dialog. Again, I will want to check heat transfer, and I want to check auto forced convection. What that does is it won't do any thermal calculations until the flow calculations are done, because in this case your temperatures are not going to affect the flow, whereas the flow is going to affect the temperature. So there's no sense in wasting time and doing all the temperature calculations as you go along. Let's just wait for it to finish the flow calculations and then automatically kick in the thermal calculations. Go back here. Again, maybe change that to 500. That's my number for the day. I'm going to go to Solution Control, ADV5 again. And that's all that is involved in setting this model up. If I click Solve, it's going to go through the calculations. Again, it's going to match the model first, and then you'll be seeing the convergence plot. I'm not going to go through that. I'm just going to bring the one that is already solved with the same exact setup. And you notice that there are two designs in this one. That's going to be my next step here to show you. If I double click on design 1, it will open up design 1 results. These are the temperature. If I hold down the control key, click the middle mouse wheel, these are the temperatures inside. So these two guys are the hottest at 126 degrees Fahrenheit. If I add a plane, and look at the velocities, and look at the vectors, and I'm going to move that plane I was hiding the air volume. That's where the fun is. And here's so that's design 2 actually. I'm sorry. This has 3 outlets. So what's the best way of, so if we go back to design 1 and scenario 1 and activate that, you have to select the particular scenario under the design and look at the results. And if for some reason you decide that, okay, that wasn't good, I want to change the design. In this case, we added 1 more outlet. So the way to do that would be to go back to your CAD model here, and that's going to be a real quick change here. I'm going to open this part, and I already have that feature here. So I'm going to move it up and over here. And what you do, I'm not going to go through the setup and everything. All I'm going to show you is how to just import it into here. I'm going to clone this design into a design number 2. So I cloned the design, and back in my model here, I'm going to save this case and close it, and this is my assembly. I'm going to save it, and when I go here in the simulation active model, I'm going to update design study. I'm going to say, okay, update my design 2. And what that will do, if I go back to my CFD here, you can see that it added a 3rd outlet, and I can go back and check and make sure that all my boundary conditions are proper and rerun the analysis, and then I can use the decision center to I can create images and compare side to side. If I go to view here, the results from design 1, and in this case, it's my design 2, and I can compare them side to side. And there's a lot we can talk about here as far as decision center, but we're not going to do that due to time limitations. But that's a very good way of comparing designs or scenarios side by side. Not just images, also output the results, numbers basically. I think we're running out of time here, so I'll leave the floor open to some questions.
And just so people are aware, that link right there actually should be CFD 11 in that last slide there.
Oh, yeah.
Yeah. So eventually all the files from this will be posted to that link, as well as the PowerPoints so people can look at it. One thing, as people type in questions in the background, I know there's John and Apollo are all there. Yeah, John Liu, this will be posted within that link, so you can download it as soon as we get it up there. So probably check back tomorrow, and it should be there. You're welcome. I'm actually going to show one thing here. Actually, Marwan, if you can go bring up the software again while questions come in. One thing I just want to highlight is at the very top, so there's, of course, the setup and the results ribbon, which are used all the time, and view a little bit. But there's also the Start and Learn ribbon and the Community ribbon. So if we go to Start and Learn, this is where, if you're brand new to the software, you can find the Start here, and that will kind of bring you into the help system, and it has a collection of a lot of those resources that Marwan talked about, as well as a whole lot of other links. The Learning Pass was an interesting idea we put out, I think last year's release, that allows you to go through, and it kind of gives you a path to follow and kind of check off boxes. So it's a good way to kind of see what your progress is or where your holes might lie. Just bring that up. So it's kind of an interesting way, going from quick starting, going to the user face, and so on. And it kind of collates all the different topics under that. So if we minimize that, and tutorials, that makes sense, and other videos, and just a general help link. So that's where, if you open up the tool and you have no geometry, you start there. Under community, if you have no idea how to find help, or you just need some sort of guidance, there's two buttons in here. One that takes you right to the forums. You register an account and just start adding to the community. Myself, Marwan, John, Apollo, other developers, we all man the forums there to some level, and that's where you can start. And if you have subscription, then you can definitely come in and give us a call or create some web cases and get some direct help. The idea station, if there's something that you just want to add an idea to, that it's a similar system as the forums. You need to create an account, but add whatever idea you have, and people can vote on those, and our product managers, they look at them and definitely look through that list to try to figure out what they want to add to the tool within the next release. If you definitely show up in the top 10, 20 ideas, you know they're looking at that, considering if it's possible. And then from there, so if you go to top ideas, for instance, within that section, what's nice here is you look at the first few, the status, meaning solution provided. It's already in the tool in one of the newer releases. Undo probably will, unfortunately, never be there. It's my guess. It must be something built from the beginning, unfortunately. I wish it was there. Enable ROI is actually Ryan Abel. He's one of our application engineers. So we want it, but certain things just aren't always easy to get. If we go back now, we've got about a minute, and I'll wrap it up. Not too many questions today. I thought there'd be more coming in. There's a lot of different things we could talk about with getting started. Marwan took it as a sort of demonstration of the tool, which is great. A lot of times when I talk to customers on the phone or on the web, they enjoy just watching how we interact with the software, and you learn a lot from that. So it's a good place to see it, and now at this point you can go through the tutorials and actually do that yourself if you haven't already. One question that did come in, gas dispersion example, I'm guessing that's like a scalar mixing. That's a whole topic on its own. We'll add that to the list of ideas. The legend bar for different images on the electronics model, is it for one specific design build? It goes cross. It kind of picks the worst case legend range and then applies that to both when you do a side-by-side comparison. So that's why it was the same for both. You can then change the legend to whatever range you want for your needs. Like if you want to isolate it to a chip on the board and really make it pop out at a designer view at work. So you can go to options.
If you left click on it, go to options.
And if you just move that max to like 100.
Or just type it in, either way.
Either way. There you go. Now if you if you close that legend window, it will update the right one. So that's why there's a little lag there once you keep it there. The question is, why ADV5 every time, and help and recommendations 85 is referred to be good for rotation. Induction schemes are basically a type of numerical method, and ADV5 is sort of our newest modeling technique. So in many regards, we're trying to eventually have one induction scheme that, as I say, rules them all. ADV5 was our attempt to make everybody go from 1, 2, and 4 right into 5. So that is why ADV5 is considered more stable, more numerically accurate, and things like that. Sometimes, for some models, it is considered less stable. So if you were to do like a free surface simulation, we would actually say use it action 1. So there's still some things that are working their way out. Yeah, so remember, question just came in. I saw Paula respond back about results mode. Can we select by group? You need to set up the groups within the kind of pre-processor first so that it comes over in the post-processor. You can't set up a group in the results because it's brought through from the solver. If you do want to create a group, create it in the pre-processor and then rerun your analysis for 0 iterations, and that will then update that group and have it in the post-processing result side. And yes, we do sonic and compressible, as well as hiding group does not seem to work. If, Marwan, if you hide the decision center for a second, I can't remember if this one actually had a group or not.
This one here.
Yeah, did you have groups? You didn't have any groups in here. One thing you can do if you go to the results mode at the bottom, and if you actually look at a results visualization discussion, I think it was the very first one we had about a year ago, we did go over this in a little bit more detail, so it might be a good one to watch. But if you actually look at least material grouping here under results and right-click on like acrylic right there, you can do various things like show and hide and outline at the step, or even hide it within the checkbox, and then that gives you some options there. They're already mostly hidden. So that's one thing you can do as well. Within the setup, same idea. Once you have the group set up within the preprocessor, you need to right-click in that actual group and then show hide within the volume setup or isolate. Okay. At this point, we went about 4 minutes over. We had a few questions that kind of came in at the last second. Again, I want to thank everybody for joining and Marwan for the presentation. We'll have another CFD webinar in a month. The topics are listed within the forums, within the Build Your Simulation CFD IQ post. And as well, if you have any further up questions, I encourage you to just post to the forums, and we'll respond to you there. And every week we change which simulation product, so I encourage you to join in the other webinars if you want to just explore the other tools that we have. I want to thank everybody again for joining, and have a great rest of your week.